record now. And now share the screen. Good. All right, I guess we can get started. So, welcome to the first in the spring series of the Karen Research webinars. Just to remind you of our website and all the interesting things that are there, let me also emphasize that if you have various kinds of workshops, job opportunities, news to share, publications, send them along and we'll get them onto the website. All right, let's go move forward here. I'm Jeff Henneberry. I'm the U.S. coordinator of Karen, and the regional coordinators are Professor Sagenbek Orunbayev and Professor Mirasil Mirzoev. Also, we have recordings of all the previous Karen meetings available at this website. The NASA Land Cover Land Use Change Program has graciously consented to provide a space to archive all of those data. And so you may check out the past many webinars there. And this one early next week will be available there as well. So today we have two presentations as usual. Professor Alexander Prishapov is from the University of Copenhagen is going to be talking to us about analyzing land use and hydrologic regimes in cross-border Mongolia and Russia's Selenga River Basin. And then Dr. Andura Nazakulova at the University of Salzburg will be providing us a land cover analysis of Kyrgyzstan using global services. And that presentation will be done using Esri's map stories. So that'll be a little bit different. 20-minute presentations followed by 10 minutes of Q&A, and enjoy. Sasha, please go ahead and share your screen.
Thank you, Jeff. Let me start the presentation. Yes, thank you very much for your time. Good morning, good afternoon, or good evening, depending on where you are. My name is Alexander Prishapov. I'm associate professor at the University of Copenhagen, and I will be presenting collaborative work of the following the international project in order to understand the change in land use and hydrological regimes in cross-border Mongolia and Russia's Selenga River Basin. A few words about me. I graduated in St. Petersburg, Russia with the master's degree, and then I moved and did my studies at Oklahoma State University and my PhD at the University of Wisconsin-Madison. Then I completed a postdoc in agricultural development in Germany, and since 2015, I'm an associate professor in the field of land system science at the University of Copenhagen. There will be a relevant question. There are many different basins in the world, but why to pick the Selenga River Basin? And one of the reasons for that, because it covers a really interesting area in Eurasia, where the people so strongly are related to the different activities related to the nature. They depend on agriculture, livestock, transhuman livestock herding. They basically depend on the natural resources. And this is kind of the landlocked transboundary region, which covers a part of Russia, so Buryat Republic, and Zabaikalia, and also Mongolia, where the 2/3 are lying on the side of Mongolian side. There are expected climatic changes. There have been a number of the publications about that, and we try to investigate the implications to the land use And obviously what we already see, negative impacts on our ecosystem functioning. Selenga River also contributes 47% of the freshwater inflow into the Baikal Lake, which is one of the iconic sources for the freshwater globally. And one of also kind of the warning signs is that there is some discussion, ongoing debate about the construction of the hydropower plant on the Selenga River Basin on the Mongolian side. So today I will be primarily talking about the Buryat part of Selenga River Basin, and it's based on preceding years of their work in a team, in international team. And there are two objectives of this particular talk and presentation. First, to evaluate the determination of the hydrological conditions and impacts on land use activities, such as the cropland and livestock production, and also project agricultural production under the changing socioeconomic and environmental conditions by 2030. So as a theoretical basis where we started, we consider that a set of the underlying and proximate causes, such as the environmental, economic, demography, and technological factors may impact the land productivity and types of the land use. The factors, they may operate at different organizational levels. That's why it's very important to incorporate the knowledge and the parameters at the agricultural producer scale, but also at the district level, where some decisions can be done about the land use. As another part of the theoretical setting, as most of the studies, if you look across the literature, they primarily deal with the correlation or the regressions. So that's most of the studies, but that doesn't necessarily mean that it results into the causation. And so the relationship, first of all, can go in both directions. For instance, the population decline can result in a land use change, but also land use change may impact the population decline, result in a population decline. So why it's a little bit tricky to use for predictions, I would like to bring an example of the balloon and the air. So if we do, let's say, predictions based on linear models, we always assume some incremental intake or put in the air into the balloon. And of course, we cannot do to infinite in certain infinite way, because at one momentum, the balloon will just explode. So that doesn't work with the autoregressive models. We cannot predict to the infinite change, let's say, with the climatic changes. The another also important notion is that with the regression, it's very hard to establish more complex way of interaction of the drivers, because between the population and land use change, there can be intermediate drivers or certain sort of the mediators. And that's why we need to account for entire causal chain. One of the solutions is to use the set of the dynamic models, and I would like him to bring the slide and the picture below of the slide, where let's say we have some amount of the pump air is a x1, and how much we put in that, it depends on the state of the balloon, whether it's going to still be alive or explode, and we will not have any volume. So based on this state of the condition, then we can determine how much of air there is in the balloon, and then we can decide how much in the next step we can put the extra air in the balloon. So this way it shows kind of the causal chain and causal inference over the time. So there is some time lag effects in the models, and this is what we would like them to incorporate if we study land use change or also the climatic changes. So as empirical basis, we also included the factors at the district or rayon administrative level 3 county, like in the United States units, with all available statistics we considered for this model. We also included parameters about the hydrology, climatic conditions from meteorological stations, and ancillary data. We use a semi-structured interviews with the farmers and the experts, also to make first of all development of the model, but also parameterization, but also develop the scenarios. And scenarios and models evaluation was also done with the participatory approaches, including also expert opinions. As an empirical basis, we decided to use a Bayesian network modeling, because first it accounts for priors and non-linearities, options to include partially missed observations. We can also construct direct acyclic graph with the causal linkages, and also quite importantly, we can evaluate these models and incorporate the knowledge of the experts. However, this is more tedious and more things has to be considered and more efforts has to be put in order to develop this model compared maybe to regression, simple regression models. Elements of the Bayesian networks, they have a nodes, so they are variables. We have a connection, so arcs, linkages with the causal inference. We have a structure of the Bayesian network, and behind of each node, we have also conditional probability distribution. If you're not familiar with Bayesian networks, well, let me show the example. So we would like to evaluate whether the grass is wet or not. And this can be based on the information about the prior knowledge. So for what are the chances of having the rain? And based on the statistical observations, we can state that maybe 20% of time when we go outside, we can observe the rain. That we can incorporate also information where certain events that are taking place together, such as a sprinkle working together jointly with the rain, how often we can see this frequency that sprinkle is working versus the rain. And this also gives us probability distribution. So as an example, on the right side, you may probably notice that if there is a rain, the chances to observe working the sprinkle is close to zero. So 99% we will not observe those cases. But the essence is coming once we combine together some priors and also learned information from the model. So then we calculate and maybe improve or opposite downgrade the probabilities of having events. And here we have a grass wet versus having a sprinkle and rain together in different combinations. So of course, if we can observe the wet grass, if let's say sprinkle and rain simultaneously are taking place, or sprinkle is working, then our probability of observing the grass can be almost like 99%. So that's kind of the bringing in the essence for us, this incorporation of information we can use in order to propagate and to learn about the model development. Now coming to the study area. So Buryat Republic is quite interesting. Unfortunately, in this news, it appears in very dramatic mode, but we study about the environment and we can learn a little bit also from environmental conditions. The area covers 14 districts, but we analyze in the study, and 80% of the rural population in Buryatia is heavily engaged in agriculture. So it's very strong dependence on what the resources are, water availability, and so on. As a demography, it's one of the few regions in Russia until recently was with a growing population, until 2021. And it's ethnically, culturally diverse region with different preferences to the farming. And I'm referring to a little bit promote our work published in land use policy on reasons for recultivation of abundant lands in this region. The population is quite dispersed, the settlements, and the climate is also quite varies a lot. So we have a lot of precipitation in the mountainous regions, while close to the border with Mongolia, almost like 150 millimeters of the precipitation. Looking at the statistics, we observed a large substantive decline of the sown areas. In some districts, the sown areas completely ceased from the cultivation. There is a polarization of the population density, livestock declined as well. So that's what we observed. About the settlements, it's also quite interesting, and I bring the contrast with Mongolian side. We see more and denser population on the Buryat side of Selenga River Basin. But at the same time, we also observe that all settlements are kind of nailed down on the roads and linked to the water objects. So the hydrological conditions are playing a really essential role in livestock maintenance, crop production, and livelihood strategies in this region. So as a selection of the variables, we selected the variables and put them in some blocks. So one of them is a population migration, social welfare, represented by unemployment and other factors, social infrastructure, beds and hospitals and other factors, agricultural land use, such as the sown area for different types of the crops, productivity, the yields or milk production, climate measured by precipitation, temperature, and other factors, and the hydrological regimes, discharge or the water flow through the hydrology stations. We use a dynamic Bayesian network modeling. So first of all, we establish the structure with strong and plausible linkages using a direct acyclic graph and hill climbing approach with score-based algorithm based on Bayesian information criteria. Then we estimated conditional probabilities using a maximum likelihood. We also evaluated the direction of the relationship and plausible causal inference using a granular causality test and expert knowledge. So we had to exclude incorrect connections. And I bring an example, for instance, kindergarten are linked, could be potentially linked with the cattle. But that's probably illogical. And what we see, there is a mediator factor in between population, which links between the kindergarten and the cattle. So that will be the correct connection. So that resulted from all possible connections, we had to exclude or blacklist 1,427 connections, and other 689 connections were retained in the model. And models that were built for Buryat part, but also for each individual district. And we'll explain why it's also quite important to consider much finer units. We use the period from 1994 to 2020. The reason for that, because later you will see also in a statistical large drop in zone areas and kind of the chaotic implications to agriculture in the first years of the transition of the collapse of the Soviet Union. As a scenarios, we use the base scenario, and scenarios are basically they're showing us the boundary conditions to evaluate how factors of interest may change or may not. And we can take extreme scenarios to see how much model reflects on the differences. And we also considered for this type of the work, look at the climatic-based scenarios. There might be other scenarios too, but that was our major focus. So we use a base scenario. So climatic and hydrological conditions will be similar to what has been before, 10 years before. Scenario 2 is kind of the slightly unfavorable. We implement some proportional decrease in the precipitation and temperature with a coefficient 0.9. And scenario favorable, it's opposite, proportional increase of precipitation temperature with a coefficient 1.1. It's also was important to check the model stability and sensitivity to the parameters. Socioeconomic parameters we all projected with a 5-year moving average. As a result, well, this is what we see with the statistics. All districts marked with each individual line, we observe drastic decrease in the zone areas, some regain in recent years. The same with the sheep and goats and cattle, a drop after 1990, a substantial drop in the first maybe 5 years of the transition, and some regain recently. Surprisingly, even the land so much decreased, the yields, they kind of still stagnated, the grain yields, and milk production there was a drop in the first years of decade of the transition. There was this kind of a regain, but now it's also stagnating. If to talk about the climatic factors, once we plotted and run the regression models also on statistical significance of the trends, we observed that most of the stations, meteorological stations, will see a decrease in increase in the temperature, annual temperature, and it ranges from 2.2 to 6.6 centigrade per 100 years. So quite dramatic, particularly on the Mongolian side. But in general, we talk about 0.3 Celsius per decade. So we have evidence that there is a temperature change and increase in this area. If we talk about the annual precipitation, the story is not straightforward. It depends on, I assume, multiple factors, such as the orography and where the study area is. So there is a both increase and decrease of precipitation. And that's why it's quite important to run the model also at the finer units, not just only the Buryat part of the Selenga River Basin or Mongolian part. But overall, annual precipitation decreases 1.5 millimeter per decade. With the hydrological stations and flow of the water through the stations, we notice that overall we talk about the decrease by 14% with the volumetric flow in summer period from May to August in Selenga River Basin, and up to 38% in Mongolian side. So basically less water reaches the Baikal Lake. Once we explored the correlations among the factors, these blocks and the variables inside, we noticed some strong linkages, so about 0.3, for instance, between social infrastructure, hydrology, social welfare and climate, population and agricultural needs and such. Once we start digging more into the details, which factors correlate, of course, population correlates a lot. What we see in all Buryat part of Selenga River Basin, negative relationship between the temperature and precipitation. But nuances are coming also the districts, and some districts have a more pronounced relationship within the population, for instance, and cultivated areas. And that's why, again, it's very important to build a model and test that also for individual districts. Once we constructed so-called a base model, this is how it looks. So we have different linkages and all statistics is behind. But the idea is also to have a plausible linkages in this model. Some interesting patterns, they start popping up. And one of the important notion that we also always consider the previous conditions. So for instance, one of the interesting relationship is between how precipitation in preceding year in the May period may impact the state of the cattle, the amount of the cattle in upcoming year. And that will also be connected to the amount of the hay fields, the amount of the cultivated area in this kind of the region, which is has been analyzed. So basically how we can project if something is happening with the precipitation, let's say it's decreasing, we would probably see through the dynamic model in the upcoming year, we will have less livestock. So that will be a potential connection. So what we see with the hydrological regimes also based on the scenarios. So again, we build a model, we project what can be happening once we change the parameters. First of all, we see overall decrease also in terms of the hydrological regime, how much water passing through the stations, what we learned. There is a dramatic drop. And with these scenarios, we see very little variation compared to what is already happening. This is kind of on one hand concern, but also a very interesting way of looking what may be the reason for that. But in general, we see that based on all the situation, we'll have less water flow, and it should be also counted in land use policies. Once we project the model into the land use, we notice that, again, the zone area already dramatically decreased in grain area, and there was a drop in livestock in the first years. So in general, no matter what we project with these scenarios, other factors, they matter more, primarily institutional factors, that would result in a large drop of the livestock. But even between the scenarios, we see if we continue with the base scenario, so zone areas and livestock will continue decreasing. So this is the green line. If we go with the favorable condition, we would expect just only by improvement climatic conditions, there will be some recultivation of lands. And so about 1,000 to 2,000 extra cropland will be recultivated by 2030. It's not definitely dramatic compared to hundreds of thousands of hectares of abandonment of the cropland after the collapse of the Soviet Union, but still there is some kind of a positive sign maybe of recultivation. With unfavorable conditions, they simply will continue of the decrease of the zone areas and livestock numbers. And I should admit, in some districts, if you remember, the zone areas almost like disappear. So this is what we potentially can learn from this small, not only exercise, but preliminary results of the modeling, that there is evidence of the negative change of the hydrological regimes and negative impact on agricultural productivity based on our modeling efforts and expert interviews. The negative climate change matters in this region, but in terms of the land use, what it matters most is the overall economic and institutional situation. And seeing that even there have been some signs of the population kind of the increase in previous decade, the availability of the economically active population matters a lot. And this should be definitely considered in all sorts of the policies in this region. District level models and expert interviews suggest about the varying magnitude and impact of the hydrological changes across Selenga River Basin, suggesting also that regionalized measures are needed for climate change adaptation. So extra considerations, the model has been parameterized and tested on a sensitivity, so it gives some plausible results. So now there is a consideration to include the measures of the productivity for pastures and arable land with the remote sensing data. We will probably move from to unified livestock units in order to compare things comparable a little bit, particularly across the cross-border regions in Buryat Republic versus Mongolian side, and making the projections, for instance, using IPCC greenhouse gas emission representative concentration pathways to show this also type of the scenarios. And finally, develop the models for the Mongolian part of the Selenga River Basin. With this, I would like to thank you, Bayerla, if I correctly pronounce in Burят and Mongolian, and we definitely open our team for any suggestions, considerations. They are welcomed, and I'm looking forward for your feedback. Thank you very much.
Thank you very much, Sasha. Very interesting presentation. We have some questions, and let's get started with them. So Pasha Groisman says, is there a water sharing agreement between Mongolia and Russia for the Selenga River Basin?
This is a really good question. I should definitely look at the documents. I'm probably not aware of that. Yeah, but if someone can point to this document, I would be very happy. To my understanding, there is a maybe mutual agreement of like memorandum of understanding of the use of the natural resources among these parts.
Great. Next question by Dmitry Aksanov. Have you used some specific software for modeling or mainly developed your own scripts?
Yes, I should thank also a colleague of mine who is a very great mathematician, Elena Ponkina. She was also a great person to model program. But before we used, actually, it can be also used the Netica and Hugin, the two software packages in the past we were using, but I think it's much difficult to implement dynamic Bayesian network model. So we had to program this entire thing.
Good. Next one. Mandak Naam says, in your opinion, how would hydropower impact the Russian part? Have you looked over the governance indicator?
Yes, thank you. This is what we were planning to look about it. So we just kind of tested the model. So we will see also different scenarios for functioning of the hydropower station. What can be potentially the implication of that?
Good. Elena Pukina says, thank you for a perfect presentation. Is that like Trumpian perfect? Okay. What are the prospects of dynamic Bayesian network applications in land use studies? What's your opinion?
Well, it's maybe a little bit ironic here that Elena is asking a question who is also behind all this work, but thanks. I think we see a lot now publications which are using Bayesian networks. And the Bayesian networks, it gives a lot of power. We're also moving away from P values and dealing with the probabilities. We have this visual graph and statistical graph, but it's very difficult to set up. And particularly still discuss about the causalities to put more considerations. So there is a lot of possibilities, and we see applications in studying the drivers of the fires or land use land cover change. I think it's definitely gaining its kind of the value, but this is just one of the approaches which may lead to the causal inference, but still the causal inference stays on the shoulders of the careful interpretation. So
I have a question from a modeling standpoint. One of the big challenges when you're working with models, you get a fit, but the data that you're feeding in has uncertainties associated with it. Have you done any kind of formalized sensitivity analysis or uncertainty analysis within the Bayesian framework? So in other words, jiggering things around and seeing how the model, you can flag which variables are important to the model, but some models are going to have, some variables are going to have more uncertainty than other ones.
Fantastic question, Jeff. I think it's really relevant, and we also try to advocate from the number of the works, and being also the person who is doing quite a bit of remote sensing work, we know how many uncertainties are with the products. So we can use this kind of the confidence intervals. If we do evaluation of certain products, we can incorporate this information. You have to build this kind of the confidence intervals in model within a range of certain parameters and also test the sensitivity. I think it's super important, and I know that there is an entire field that's called error propagation in the land use modeling, and it's definitely has to be considered, and perhaps we should also consider that as well.
Okay, we're going to take one more question, and then I'm going to have you type the rest of the questions so we can move on to the next presentation. So Alexei Terekov says the increase in forecast average annual temperature may have a multi-directional effect on hydrology. The warming of winter is neutral for hydrology. The warming of summer is the loss of moisture, is the test region with warming, which is warming more or winter.
Well, I will. Thank you very much, Alexei. It's also very, I mean, key scientist in Kazakhstan and working. It's such a pleasure to have such responses from the colleagues. Indeed, I mean, we also need to account for available also the hydrological regimes and include the parameters. And here I was showing only between May and August, but we can also model for other periods and to see how this model also reacts. And this is, in fact, we also did, including different periods. Of course, the model, I should also say that it's some simplification of the reality. So we should also consider, we can model certain parameters or certain events, but we cannot replicate entire nature. It probably would require more complex model, maybe a dynamic vegetation model, and but we cannot maybe include some other factors in the dynamic vegetation model, but we can include here, for instance, socioeconomic factors. So saying that we can model something, yeah, to address specific questions, but there might be way more nuances, and hopefully there will be more studies to go in more deep into this type of the work.
All right, thanks so much, Sasha. You can get busy on answering all of those questions. We also have some information important in the Q&A. Look forward to seeing those publications. All right, Anura, will you please share your screen, and Sasha, you can unshare yours.
Yeah, just a second, how I should, sorry, stop sharing, yes.
All right, Anura, there we go.
Okay, good afternoon and good morning for some part of the world, maybe for some even good evening. So thank you very much for this invitation. Today I would like to present you this case study, land cover analysis of Kyrgyzstan. I have to admit that the title is a bit misleading, as this is not much about the Kyrgyzstan itself, but also not focused on land cover. But I would like here to bring to your attention this subtitle, and would like to demonstrate using Kyrgyzstan land cover case study. Using this case study, the power of globally available open data and the technology we have at our hands to do not only monitoring and visualization with cloud-based computing, but also to do special analysis. So this will be my main focus of today's talk. And as you can see already here in this page, I'm representing University of Salzburg, and this work was done together with Professor Strobel, and I'm scientist at this senior scientist at this university. So let's go further. Just as you can see here, satellite images nowadays enabling us to derive information about land surface, particularly land cover. So nowadays we have nearly daily coverage of all regions of the world, of the globe, with the remote sensing imagery, and most of the Landsat and Sentinel data are open data. So we can monitor this data, like I'm demonstrating here, and look at what is happening on our globe. Even more interesting will be just not monitoring, having just visual inspection, but also using algorithms to extract different types of land cover. Like here you have an example of land cover from European Space Agency. And this actually translates this radiometric information RGB values of the image into the semantic description of our land cover here. So if you just, for example, click on any point on this land cover part, you can see the description of this point. So why do we need to monitor land cover, and why it is so important for us? Clearly, land cover, one of the leading and one of the foremost indicators of for climate change and impact of climate change. There are also influences from socioeconomic and demographic factors like population pressure via economic activities, and just as well resources extraction like mining or similar activities as contamination with different types of pollutant reflected on our land cover. So these three reasons, just possible reasons, and there can be some more, and for sure there are. And we will be, because of this, interested in monitoring land cover, which means detecting change on our land cover, detecting change and assessing it. So before to go further, I would like to introduce you some global data sets, and this is first one is I hope it's visible completely. This global data set is of climate change initiative of European Space Agency, and has 36 classes and with the resolution of 300 meters. And of course, it's possible just to go and see the, okay, it needs a bit of, sorry, to see a bit more about this data and go through the metadata of this data. And this is service available to all ArcGIS online users with organizational account. So let's go to the next, maybe I can just go around a bit and show that this is the classes here. And let's see next global land cover. This is the Copernicus Global Land Service, and this was actually released in 2019 for the year 2015, and then today now we have annual updates covering the period from 2015 to 2019. This data set has 23 classes, and you can just we can just play a bit, and it takes a bit of time. So we can look at the forest and all forest types. If you can see here the legend of the land cover, and it's also possible to see the for different time period. So like this. And of course, if you want to get more information about this data set, it's also possible to go and read about these data sets on the Copernicus webpage. Next one, what I want to highlight more will be the Global Land Cover Base View 2013. Actually, this data set has covers entirely Earth area, excluding Antarctica. And this land cover is derived from 9,200 Landsat 8 images, and has the highest spatial resolution, 30 meters, and has 16 classes. And here, for example, you can see the we can select only the, for example, class forest, and this is very clearly visible here because Kyrgyzstan has not so much forest, but most of the forest covered area is located in West Tian Mountains. So, and the next one will be, okay, sorry. I have to. Just a moment.
Some of the challenges.
Yeah,
being
just
online.
okay. Let's go to next one, and this is the last one. Is what I want to show. This is the Sentinel-2 global land use land cover data, and this has actually. This was released in 2020 and has 10-meter resolution, and it's also one of the, I think, the best land covers with best resolution at the moment. So, and of course, if you go, I'm just scared to make a tip again some link, but if you go, you can get some more information about the this Sentinel data. So monitoring land cover. Okay, monitoring land cover on the national scale now has become quite feasible due to the free and open availability of vast amount of remote sensing data. And here, for example, we were using for our analysis following data as an elevation. Okay, I think you don't see so well, yeah, just I have to, I think, refresh my story map. Just a moment. Okay, now I think it will be better. So, and here you can see, for example, elevation, which is worldwide dam. And we also can work, we also worked with a derivative of this elevation as a slope. And here you can see the slope of the Kyrgyzstan, part of the Kyrgyzstan. And also here you can see a draped land cover above the elevation model. And this is, of course, more the visualization, combining elevation and land cover. And of course, it's possible to explore further just looking around this map. But let's look potential results of analytical overlay. So let's go back to Kyrgyzstan and do them and look at these two examples. In our study, we demonstrated the categorized aggregation of land cover statistics for the territory of the whole Kyrgyzstan, which has area around 200,000 square kilometers. And here, okay, here let's look at the statistical analysis of land cover class distribution by 100-meter elevation zones on the left side. This is on the right side, you can see the classes with their graphic distribution. And actually, the elevation of Kyrgyzstan goes quite from 400 meters to the 7,000. So quite good diverse area in this sense. And let's look at the second column here. This is a hypsometric curve of for the entire country, and you can see that the distribution of the area according to the related to the elevation. And here maybe you have noticed there is a peak, and this is peak really the our Kyrgyz biggest lake is Sekul, and it's situated on the elevation on at 1,600 meters. So let's go and look at some land cover classes here and compare their hypsometric curves. For example, evergreen forest and here, and the grassland here. And you can see here that grassland has higher frequency in lower elevation, where evergreen forest is peaking higher up above and beyond this 3,000 meters elevation. And if you look at barren land, is even higher than evergreen forest and exceeded by ice and snow glaciers here. So, and if we look at agricultural land, you can see that it's mostly focused on the lower elevation, and here you can again see the peak. This is the agricultural land around the Sikul Lake, and here the agricultural land in Chui Valley, and here is, for example, agricultural land in Fergana Valley of Kyrgyzstan. And the same, if you look at the paddy field and rice cultivation, usually happens here in lower elevation in southern part of Kyrgyzstan. Similar discussion we could have about urban and built-up classes here. So this is entire balance of the country, which would be the distribution of land cover classes over 200,000 square kilometers. It has been analyzed at ground resolution of 30 meters cell and broken down into elevation zones by simply doing zonal overlay between land cover and elevation zones. So the same way, I would like to demonstrate to you the land cover by slope. Here we just needs a bit time. So you can see statistical analysis of land cover class distribution by 5 degrees of slope zones. As you can see here, most of the agricultural land is mostly lies on flat area. And it's most of the area lies from 0 to 5 degrees slope zone. The same we can say about the urban area, grassland, barren, and are well distributed from 0 to 50 degree slope zones. If you look at this and this columns. So let's go back. So, okay. While we are making analysis for entire country, it is possible to break it down the way of generalization. And here you can see the example of data generalized and simplified into the hexagon with area of 100 square kilometers. So this map actually shows zonal majority aggregation, where each hexagon represents quantitative majority class from all classes fallen into this area. So here we can say that we can see the dominant classes covered in this hexagon. The same way, here you can see zonal variety aggregation of land cover with the same parameters like 100 square meters hexagons. And here we see how many different classes fall into one hexagon. For example, the darker hue, the more different number of classes are represented in this individual cell. So this land cover classes was mapped using base view 2013 land cover, which I was mentioning above. And I'm going to my final part of presentation. I would like to summarize a bit what I wanted to demonstrate here. So before we were downloading images, importing them and saving them on our own repositories, computers, desktops. But today everything is changed and we have flood of data. Nowadays, global data sets and services are homogeneous and available on online services. And for example, our overlay terrain and land cover was this example of it. And these all services actually and adheres standards. Knowing their coordinate system and special reference system, we can integrate them data from different sources. And for example, for our case, we were using data country boundary data from global data sets and masking. So this integration was seamlessly done. And these all data sets are openly available, particularly all of them found in Living Atlas of the World, which is essential data collection and part of the ArcGIS Online ecosystem. So, and of course, most of the analysis nowadays can be done online. Cloud computing also gives an opportunity to do sophisticated analysis without having powerful software installed on the local computers. So this was my message, and maybe at the end I want also to invite, because this is the network of people who are mostly connected with Central Asia. I would like to invite you for the GISCA 2023, which will be actually happening in May 30th and 31st in Bishkek. So welcome. Thank you for your attention.
Thank you very much, Anora. I have a question. So
oh my God. Okay, have to.
We have this lots and lots of data available. And as you
Yes.
have shown, we have land cover data at 300 meters, we have land cover data at 30 meters, we have land cover data at 10 meters. So we have increasing spatial resolution, but one of the challenges, I think, to really engage the land cover data in to address local problems is we only have a very few number of land cover classes. So if we're looking at global stuff, just a few is fine, because it takes, how you fit these different things in. But when we're trying to address particular kinds of conservation problems, then we want more thematic resolution, right? But there's been this big pressure towards higher spatial resolution without enough looking at the thematic resolution. I think that that's really where we need to move forward on, to make, we demonstrated that we get things down to very fine spatial resolution. But what's the difference between having one or more pixels in a crop class versus a grassland class, when they're so completely, I don't know, we've pushed very far. Now we need to do the very hard work of going from global statements about land cover to very local statements that are much more relevant to decision support. And to that point, in your analysis there, you had a land cover class called paddy. Is there paddy agriculture in Kyrgyzstan?
Yeah, we have rice in southern part of the Kyrgyzstan, and it's Uzgen region would be, and we have very good rice actually, which is very welcomed by everyone when they have some special festivity. So to use this type of rice. So
I just learned something new.
So big.
Thank you.
Yeah, it's not area, of course, it's not as big as in other countries, but I think yeah, we have just for local use.
Good. Okay, so we have some more questions. All right, new and different questions. So Alexei Terekov says, Kyrgyzstan, natural zone with high variability of seasonal weather, very wet years, very different from a very dry year in terms of moisture content. Accordingly, it's unclear what map with such a generalized land cover classes reflect. Forest is stable, but other classes are very dependent on moisture regime. Land cover classes on conditionally average long-term conditions, So in other words, that challenge, obviously, I think he's trying to get at the fact that vegetation communities can change. And it may be difficult to, a land cover classification at a particular time. And we know this, the shrubland to grassland, problem. Some years or grassland to barren problems. If it's a really dry year, you do the thing and all of a sudden it looks like the grassland is barren. And the next year there's a grassland again. So any thoughts on that?
Okay, I think I would say that annual maybe analysis would be very interesting in this sense, how they're changing the vegetation with this period of a year. And of course, we have different local areas are not that easily comparable. Also, Kyrgyzstan is a bit in the sense of we can say still stable, that grassland will be there, but the type of grasses would be different. And it's not so easy maybe with the remote sensing technique to distinguish this all. And this, I think, some local challenges, and we have to use ground truth for this purpose also. I'm saying as a not really a real expert in remote sensing, but and it's also important to not just to use the remote sensing data, but to integrate to these different data layers, which are available. So of course, here I was demonstrating only using that very easy available land cover data. But when we are going to more the decision making or precise analysis, we need more data, more layers. So, and we should integrate all this data in order to make maybe just modeling, and then based on the modeling, we can have some solution. So I don't know if I answered the question.
So Elena Pukita says, can we apply these services to Uzbekistan or Kazakhstan? And I think that probably, these are global services, right?
Yeah, this is global services. Maybe I didn't mention during my presentation. Yes, this data is global data available for all countries. And actually, it's very transferable from one country to another country. Here, I was just taking example of Kyrgyzstan because I know better the land and the area. So of course, for the territory of Kazakhstan, it's very valuable because it's quite big, and this land cover data, I think, very useful. The same, I think, Uzbekistan.
Mm-hmm. So this gets us down to the last two questions dealing with validation of land cover data sets. And I think that this is a big challenge. To what extent have there been validation efforts that you were aware of?
Okay, thank you very much. Actually, as I was understanding, going through this all land cover data sets available online, their quality is quite high because, for example, I don't remember which exactly from these data sets was that they are really taking a quite good validation, and it's higher than 80%. So it's much better than when we maybe locally do on ourselves, as sometimes it's not so easy to make ground truth and do the field work. And in these data sets, I think they have quite good, in this sense, quality check.
All right, good. Thank you. I would argue that, but that's something to do later. So I want to share one last screen here before we sign off. I want to announce the first. This is the first announcement of a Karen Regional Workshop. It's going to take place in Cholpon-Ata and Issyk-Kul this September. And the 13th to the 16th, and we're going to have a few days of geospatial training for early career scientists at the American University of Central Asia in Bishkek in advance of that. So we're still working out the details. There's lots of details to work out. Doing one of these hosting things is a lot of work. But we stay tuned to the website. I also, if you're on the Karen mailing list, I'll be sending out information associated with this effort in that way as well. Join us next time. It's going to be a month from now, March 3rd. I messed up the slide. I don't have it ready, but I'll send out the announcement later today about who is going to be giving talks next time. So thank you very much for your time and your attention, and see you in a month.
Thank you.